Algebra under control, then we will be able to do the geometry. Okay? As I start this, you should remember it from last year, but I'm going to assume that you don't and start from scratch. That way we don't have any problems. Systems of equations look something like this. That look familiar? If I graph the top equation, what would I get? If I graph the top equation, what would I get? What would it look like? You said?
Oh, it would be like a line with a negative slope.
That's it. All we need is, it's a line. What's the bottom equation look like?
A line.
A line. Excellent. Okay. Are we really that far behind in algebra that you don't realize that those are lines? Or are you just too bashful? Because if you don't realize those are lines, we're going to have some big, big problems here. How do I know those are going to graph to be lines? Colin?
Oh, you can like divide them and or like put them in like a slope form.
No, you're not answering the question I'm asking. You're answering the question, how do I graph those lines? That's not what I want to know. I want to know, how do I recognize that that's going to graph to be a line? Listen. They have an x and a y. That's the first step. And? No.
Both to the first power.
They're both to the first power. Very good. Occasionally we can get a line if we just have an x or a y and a number, but the key is they have to be raised to the first power. If that x on top was an x squared, we got a different animal. That comes later. What can you tell me about those lines in particular? Do they have the same slope? Nope. So if they don't have the same slope, what can you tell me about them? Herman.
That they're not parallel,
Which means?
they're intersecting.
Good. And what's their intersection look like?
I don't.
Here we go. A point. Good. So what we're going to end up finding when we solve a system of equation is the point where those two lines intersect. And there's a couple different ways to do it. We're going to start with the first method, which is called substitution. Substitution means you take one equation, you solve it for one of the variables, you plug it into the other equation. I have four choices. I could solve the top equation for x, plug it into the bottom. I could solve the top equation for y, plug it into the bottom. I could solve the bottom equation for x, plug it into the top, solve the bottom equation for y, plug it into the top. And you'll learn as you do more and more of these, some of them are smarter than the others. Like for instance, if I solve the top equation for y, I'm going to get some fractions, and I don't want to work with fractions. I want to avoid fractions as much as possible. Natalie, put the iPad away. You don't need it right now. So that narrows it down to three possibilities. The top for x, the bottom for x, and the bottom for y. Simon, what would you like to do? Top x, bottom y.
Top of X.
Top x. Okay. So I'm going to take this top equation and solve it for x, meaning I'm going to move the 4y to the other side. So x is equal to negative 4y plus 8. Now, take this stuff and put it in here. And that's where the substitution comes in. I'm substituting for x this value. Opposite of negative 4y plus 8, close parentheses, plus y equals negative 7. Is this a solvable equation? Yes? How do you know? Only one variable. Okay. One variable should be solvable. So let's do that. 4y minus 8 plus y is equal to negative 7. So that's 5y is equal to 1. And therefore y is equal to 1/5. Now what? How do I find x, Alex?
You have y, so you plug it into one of the equations.
Where? Do you care?
Well, no. You
No.
get the same answer.
Do you have a preference?
Yeah, the normal one without the coefficient
This one?
on the bottom. Yeah. the
Okay,
equation.
let's plug it in there then. So negative x plus 1/5 is equal to negative 7. So negative x is equal to 7 minus 1/5 is negative 36/5. So x is equal to 36/5. One thing you also have to get used to is we don't necessarily always have nice, pretty answers in here. And in fact, I'll show you how to solve some really nasty ones later on. Whoops, not x. So now, since it is a point, your answer should be in the form of a point. In parentheses, separated by a comma. And getting back to what Alex said, it doesn't matter, once you have y, you can plug that into anywhere you want. You can put it in here, here, or here. It doesn't matter. Does this look familiar to people?
Yeah.
Question?
Can't you like multiply the set of points by 5 so that the denominator?
Absolutely not. It would move it to a different location. Any questions before we move on? First method, substitution. Now, sometimes the problems will, whoops, wrong way. Sometimes the problems will tell you, use the substitution method, use the next step we're going to do, which is called the elimination method. However, other times it'll leave it up to you. So part of the challenge for you is going to be figuring out which method to use. Okay, let's try this one. Solve that using substitution. Go. Don't be bashful about using those calculators either. When you're done, check with your neighbor to see if he or she has the same answer. If not, fight about it. There you go. Good. That's all right. Well done. Okay. Now, she made a smart choice from the start, and that was she chose to solve the top equation for x. Why was that a smart choice? Because it eliminated fractions. If she solved the top equation by 2, then she'd be dividing by 2, which is going to create a fraction. Bottom equation, if she solves for either x or y, you're going to get a fraction. Again, we want to try to avoid those as much as possible. So everything else is pretty straightforward. Solve the top equation for x, plugged it into the bottom equation, solve for y, got a value for y, plugged it back in, got a value for x, gave her answer in the form of a point. Any problems? Nope. Hot diggity. Let's move on to elimination then. So again, that's the substitution method. The elimination method then works a little differently. Looking at that equation, I could do it just like Caroline did the previous problem. I could solve the bottom equation for, let's say, x and plug it back in, but we want to use the elimination method. The elimination method involves multiplying either or both of these equations by some number so that when I add the equations, things drop out. So, for instance, the first one I'm going to do, I'm going to choose to multiply the bottom equation by -4. Why did I choose -4?
Because if you multiply by that, negative, it goes to -4x, and then the x's cancel.
Good. You have to multiply everything by that number. So the top equation stays the same. Just going to rewrite that. And the bottom equation is going to get multiplied by -4. So that's -4x plus 8y equals -52. Now add. 4x, -4x cancels. 3y plus 8y is 11y. And -52 plus 8 is -44. Oh, look how nice that is. Y is -4. Now I have to plug that back in. I got a whole bunch of different places to plug it back in. I'll plug it back in, let's say, here. Okay, so x minus 2 times -4 is equal to 13. So x plus 8 equals 13. So x is equal to 5. 5 comma -4. Now, what else could I have done? If we go back to the original equation, I could have multiplied the top equation by -1/4. I don't want to, but I could. I could multiply the top equation by 2 and the bottom equation by 3. That's going to cause this to be 6y and this -6y, and the y's would cancel out. You have a lot of different options here.
Could you also multiply by 4 and then subtract it if you don't, like if for some reason you don't want to do -4?
You can, but what I find is that when people do that, they have a they're more likely to make a sign error. People are less likely to make sign errors when they're doing addition.
Okay.
Okay? But you can, yes, it would still give you a valid mathematical answer. Good? Questions on elimination? Okay, here's one for you. Whoops, that's an X. Sorry, it's a big X. All right, solve that using elimination. Might get some big numbers, but that's okay. All right, let's do this. Turner, what did you choose to multiply what by?
I chose to multiply the top by 3 and the bottom by 2.
So I am assuming we're getting rid of the y's.
Yeah.
Okay, good. Everybody use the same method? Yes?
Yeah.
Natalie, what'd you do?
I use the same method, but I multiply one by a negative number.
Oh, you want them negative.
One of them.
Which one did you do both positive?
Yeah.
And then what, subtracted? Oh, I don't want to subtract. I'm gonna, which one would you like to be negative, the 3 or the 2?
Doesn't.
It's your call.
2,
3? Okay. Because again, I like to add, I don't like to subtract. Okay. 21x minus 30y is equal to negative 33. And negative 16x minus no plus 30y is equal to 68. Now, what else could you have done? You could have multiplied the top equation question, or you can answer my question? Go ahead.
I did like the more difficult way. I don't know why. I multiplied the top equation by negative 8 and the bottom one by 7.
It's not more difficult, it's just different. You just got different numbers, right? Did they get big and scary?
Kind of. Yeah.
Are you afraid of big numbers?
Not really.
Good, then it's not a problem. All right, and again, I like to add. So we get 5x, those go away, equals 35?
Yeah. 45.
35.
35.
It's 35.
35.
7. Last time I checked, 35 divided by 5 is 7. Okay, I was just seeing who's paying attention. All right, Turner, where'd you plug that back in?
And the top.
Top equation?
Yeah.
Okay, so negative 7 times 7 plus 10y is equal to 11. So negative 41 plus 10y is equal Is that what you got? Is that what you guys got?
Yeah.
Okay, good. Let's suppose this is a quiz question, and I've got some time. There's 10 minutes left in the period. I finished the problem. I want to check to make sure that's correct. How do I check it? Go ahead, Kelly. Yeah.
You would plug the numbers in the equation, or the numbers in the coordinates back into the, like, 2 equations.
Yeah, you got to plug them into both. Right. You got to make sure they work in both equations. If it gives you a true statement in both equations, then we're good to go. Okay. So substitution and elimination, and like I said, sometimes you'll be told what method to use. Other times you can do whichever one you want, and it's going to become a matter of what makes you more comfortable. Okay, I got 2 more examples. Solve this one. Whoa, that's horrible. That's supposed to be a brace. Solve this one using either method. I don't care which one. Real quick, what method are you using?
Substitution.
Because I already solved the bottom one for y.
Yeah.
Probably a good move on your part. Hold on, on the back. I'm okay. I'm a little confused, but I'm okay. Yes, you got no solution.
Yeah.
Not no, you didn't get no solution. So that would be 3. No, you didn't get no solution. That's 4. We have to have an odd number. No, I didn't get
It did
no
get-
solution.
Yeah.
So that would be correct.
Yeah.
Right. What'd you get?
No solution.
Why?
Because when you plug in the 8x minus 3 into the y,
Uh-huh.
after you solve that, you get negative 3 equals negative 2. Oh, whatever. Yeah, negative 6.
Close enough. You get two numbers that aren't equal to each other.
Yeah.
Everybody else got no solution? What does that mean? How's it good? No, those are both lines.
They don't understand. They don't understand.
Is it everything?
They don't understand.
There's two ways that they can not intersect. Which one's going on here? Emily, any idea? No? Anybody else? Natalie? Say again?
They're parallel.
One option is they're parallel. Other option, Tom? Nope. No, because we're doing two-dimensional stuff.
They're the same line.
They're the same line. Which is which? Are those the same line? No?
C.
Yeah.
Maybe. C. No, maybe. Yes, no.
I don't think so.
Yes, no, maybe.
Yeah, they're not.
How do we find out?
Wait.
You
We
don't
saw
find
it.
this
You don't. You can't. It's impossible.
Find this low.
Can't be determined.
It doesn't
Use
matter.
it's fine.
Ask the
Yeah, you ask the teacher. Use Google.
Google it.
Google it.
Mr. Google. Oh, they are the same line. They are the same line. They are the same.
Are those the same line?
Yes.
No.
Yes, they are. Okay.
Well, they're not the same.
Parallel.
Okay, I must not know what I'm talking about.
They're parallel.
These are not the same line. How do I know they're not the same line, Matt?
Because they're different Y.
Different y-intercepts, correct. Okay. They are parallel. Same slopes, different y-intercepts. That's why we got a false statement. If they are the same line, you would get a true statement, meaning it would end with something like -2 equals -2. Irregardless, or regardless? Irregardless. Forget it. Irregardless. Regardless. Not irregardless. Going into that again. Anyways, here's what you need to know. Those lines don't intersect. They're parallel. Right. That can happen. Last example. This will be fun. We're going to do this one together. Whoops. Pregunta.
On the test, if it's no solution, will we have to say if it's like the same line?
You might. Yeah. So when you're solving it, if you get a false statement, they're parallel. If you get a true statement, they're the same line. Okay. What method do you recommend I use here? Charlie.
Elimination.
Elimination would be a good call. And what would you like to multiply the top equation by? 2. And the bottom equation? 7. So we're going to get rid of the x's. 14x minus 8y is equal to 16, and negative 14x, oh, that makes me happy, plus 35y is equal to 21. 27y is equal to, uh-oh. Ooh. Oh yeah. Ugly numbers. I don't know about you, I'm okay with that as an answer, because I'm pretty sure I did my math correctly. What I'm not very comfortable with is figuring out what x is. So I'm going to show you how to use your calculator to do that. Take this number and store it into y. And I've showed you how to do that, but I'll review with you. 37 divided by 27, enter, store y. And remember, you get to y by doing alpha and then the appropriate number, which is, Alex, where? Y is above the what? I don't think I can see that in my line. It's above the 1. So store alpha 1.
How do you store?
Stow. It's on the left-hand side, second from the bottom.
Oh, I see.
Okay? So now your calculator, whenever you type in y, is going to give you that value. So now I need to plug that value back into the equation. I'm going to put it in, let's use the bottom one. So I'm going to take and solve for x. So start with the equation, negative 2x plus 5y is equal to 3. And then negative 2x is equal to negative 5y plus 3. And then I get x equals negative 5y plus 3 divided by negative 2. Now, what you can do on your calculator is on the home screen, literally type in that equation. Negative 5 times y plus 3, enter, divided by negative 2, enter, and convert it back into a fraction. Let me go through that again.
Yes.
Negative 5 times y plus 3, enter, divided by negative 2, enter, and convert it back to a fraction by doing fraction enter, math, enter, enter. What's x turn out to be? Let's say what?
52 over 27.
Ooh. That's ugly. With the use of the calculator, we should be afraid of no system of equations at all. And to prove my point, we're going to do the following. Colin, what day of the month were you born?
Like dates or day?
When's your birthday, Colin?
August 16th.
16th?
Yes.
Beautiful. Matt, what year were you born?
2002.
2002. That was a while ago, right?
Yeah.
Okay, so we're going to do negative 2y. Alyssa, how old is your dog? How old is your cat? How old is your grandma? Guess. Your grandma's only 60 years old? Your sister is what? 16. How tall is your sister? 5'3", and in inches, that's how tall? 63 inches. Good. Bree, what size shoe do you wear?
Like
4? That's really small. Okay. Joanna, how much can you bench press?
50 pounds.
Shut up. Guesstimate. Okay, there's money on it. How much? Just one time.
I don't think you
Yes.
The bar is 45.
Yeah, the bar's 45. So slap a couple 25s on each side. 95. You can crank out 95 one rep. How much? 45. Okay. Are you uncomfortable with that? No. Okay, so that's positive 45. And
Yeah.
0.
Franny, you have Spanish, Italian, French.
Yes.
What classroom?
104.
104.
124.
124.
120.
Okay, good. Solve that system.
Wow.
Oh yeah. Time to run with the big dogs, kids.
Big dogs. 150. roll with the cross, my guys.
Hopefully they're not how weird would it be if they were parallel?
That would feel so good.
If those lines are parallel, I'll give everybody an A on the next quiz.
Oh, if they're parallel, okay. Let's make them parallel.
You have to believe.
Let's bend the lines.
It's actually not as bad as I thought because of the X's.
Yeah.
And we're looking for an exact answer, so your answer should be in fraction form. I don't think anything's going to turn out nicely. If it does, that would also be freaky,
You have to believe. If general
especially given the fact that we used Colin's birthday, Matt's birth year.
You have to believe.
Where did the 63 come from?
House.
Alyssa's sister. And Bree's incredibly tiny shoe size. How much Joanna can bench press, and what room Franny has Spanish in. French, sorry. French. Hurry, bell's gonna ring. Right, quarter after? Keep going, come on, get an answer.
I got the first three digits of five.
Go. Hope this doesn't like unlock a portal to another dimension.
The parallel.
Anybody get either one of the variables?
Nope.
What's y?
559 divided by 78.
Wait, oh, y equals what? 500
559 divided by 78.
Oh boy. Okay.